Having understood the problem statement for the flight path problem, let's see and analyze how we can go about solving it. The first observation that I want to make is that, look, this is not a problem that directly fits into the mold of find a given value in a list. That was a search problem. We have a list. We want to find a particular value in there. This is not the same problem. In fact, what we are doing here is to find the first instance where a certain condition is met. Which means that in this case, for example, the first item where, for example, the value of the item is more than the threshold that's given. So this, while is not, let's say, a direct search problem, but still there are clearly similarities. The list that we are talking of is also sorted. So let's just kind of go back to the drawing board and think of all the solutions that are possible. The first thing that comes to mind is, well, straightforward linear search, right? So we can just go to every step, basically go at every item, look if the threshold is crossed. It will tell us the first item where the threshold is crossed. But this is bound to be slow because we're going to just check for every item. So imagine the threshold is crossed at, let's say, after a million items, we're going to do this a million times, right? So clearly we've seen this. This is going to work. It's going to be correct. However, it's going to be slow. Since the data is sorted, we have an option to do a jump search. So we can do large steps, maybe square root of n. And then, you find that if the threshold is crossed, then, we can come back and do a linear search to see where the first search occurrence happened. Again, this is going to be correct. But given that the data is sorted, given that the list that we are dealing with is decidedly non-decreasing, clearly the right approach to think about is binary search, which is to say that, okay, let's start in the middle. If the threshold is crossed, move backwards, otherwise move forward. Keep doing this until the threshold is, until you find that item where the threshold is reached, right? So just like in a regular search problem, binary search turned out to be a lot more efficient. The same thing we'll see here, and hence binary search is the way to think about it. Now, the interesting bit is this, right? That, look, even though we don't have a, let's say, regular search problem, but there is a nice, let's say, structure to the data. If you look at altitude versus the index, clearly this is a non-decreasing function. The point to realize is that at any given index, I know whether the threshold crossing is ahead of me or behind me. So what does that mean? How does it help me, right? So I do a binary search. Remember, in binary search, we are always searching in the middle. So when I look at the middle, I know that I'm below the threshold. I must move forward, which means that I can immediately discard, let's say, this part of the list. Now that I know I need to move forward, I can go in the middle of here. But having jumped, let's say, to this point, I'll realize in this diagram that, look, the threshold crossing is now behind me, and hence I must go backward. I can go and discard this part of the list, and so on. Keep doing this, and you'll realize that in logarithmic time, you will find the first value where the threshold is crossed. But as usual, writing binary search code requires care, and we will talk about that as we start writing the code. But the point that I'm trying to make is that binary search makes sense here since the list is sorted. We assume, and rightly so, that the plane is either holding the altitude or it's going high. So the list may have repeats, but the values are completely non-decreasing. Now, what this implies is that at every index that we are searching, there's a very, very clear demarcation whether the threshold crossing is ahead of me or behind me. And that's what dictates the binary search. Of course, we'll have to adapt binary search to, let's say, solve this problem. And that's what we are going to look at in the next video. But I hope you found this discussion interesting. Important to understand and realize why binary search is the right choice for this problem, because that's when we are able to apply this to other problems as well. Do look at our website www.ybyte.in for more such content. Take care, enjoy programming.